Hello, this is David de Hilster. I am a critical thinker, dissident scientist, and I'm here to tell you the truth about science, something your university professors won't tell you, the math media won't tell you, of course, the science evangelists on TV won't tell you. This is a great day, I tell you, and I get to speak to a Brazilian in English who really speaks English quite well, but a great friend and colleague, and I have here today from Campinas, Brazil, right? Andre
Yeah,
Assis. Welcome, Andre.
thank you very much, David. I'm very happy for your invitation for this interview.
Well, I'm sure this won't be the last because you and I are really mechanical people, and my dad and I are working on total mechanical. And I even said to my dad, I said, I know if I talk to Andre Assis, he's going to like our model. Right or wrong, he's going to like it. And you definitely are. In fact, I don't want to go ahead of myself because I have something to say that you said many, many years ago that stuck in my head. And I turned to my dad and that's a story we'll tell later. But let me tell you a little bit about Andre Assis. If you want to read a great book, this is Rational Mechanics. I'm showing it on screen here,
Re
Andre.
Relational
Relational.
mechanics.
What did I say? Rational? Well, it actually is rational, I think. But it's the name of the title is Relational Mechanics by Andre Assis, and we can get this online, right?
Yes,
Okay.
it
And I'm
is
gonna
available.
yes, I think on Amazon. But
Yes.
and so Andre, you can see this, but let me read the back cover, which really tells you about Andre. Andre Assis was born in 1962 as a professor of physics at the State University of Campinas, Brazil. Yes, he's a he is a professor of physics and actually is a dissident science. We're going to talk about that aspect of it and hopefully not get in too much trouble. He held a postdoctoral position at Culham Laboratory in England in 1988. He was a visiting scholar at the Center of Electromagnetics Research, Northeastern University in Boston from 1991 to 1992. He has published dozens of papers on relational mechanics and Mach's principle, Weber's electrodynamics and Ampere's force between current elements, Hubble's law of redshifts, the cosmic background radiation, and cosmology. He is the author of Weber's electrodynamics from 1994 and 5 other books in Portuguese on related subjects. And I welcome you very much to our Dissident Science, which is growing, and I've been talking about you, but I think people are saying, "Hey, I want to learn about some scientists." So, I think the first curiosity before we even get into the physics, tell me what your position is in the university. And we have many cases of people in positions in university not being tolerated there. How do you say outside work, which may not agree with mainstream. So, what is your official position at this university?
Yes, I have been teaching at the University of Campinas since 1989, and that's fine. I'm very happy with my position there. I have freedom to work, and so that's just great.
And so you teach regular mainstream physics to your students.
Yes,
What are the
exactly.
courses that you teach in particular?
Classical mechanics, classical electromagnetism, Mach theory, and so on.
And when
But
you go ahead,
yes,
go ahead.
but I also make research and supervise master and PhD students on Weber's electrodynamics and relational mechanics and these topics.
Wow. And I guess one of the things it seems when you do read your work, people you don't get the feeling that you are really dissident. For instance, like the particle theory my father and I have, we're redoing that. Even though you're using equations and that maybe your equations actually mesh with our model, you're I think one of the biggest questions is why aren't you being kicked out of the university if you in fact disagree with certain parts of the mainstream science?
Well, I don't know. I think I have tenure position, and so and I do what I need to do at the university: teach, supervise students, work normally, and so that they allow me to do that, and so that's fine.
Do you teach anything, for instance, when you teach relativity, obviously there's questions about relativity in our group. Is that something you just normally teach the way all other professors, you don't go into the side of, well,
No,
they're,
normally I don't teach relativity.
oh,
I
oh,
just
okay.
teach classical mechanics and classical electrodynamics and these topics.
So I think because of your topic area and because of your interest, you have a less of a clash in this area where you're at than if you were to say be a person like Dr. Edward Dowdy from NASA who says, look, we don't see bending of light outside of the corona of suns, that the bending of light is really a mechanical thing because you're hitting mass. You're not in an area that's going to be controversial by even your students. Is that a pretty good assumption?
I don't know. Many things on which I work, they are very controversial, but I express myself very openly.
Right, right. Okay, and one of the things is we have a fellow colleague in Brazil. He is Luiz Sarobon, and he is an engineering teacher, and he has given papers at our group, which have really been great papers. He's done mechanical models of color.
Yes, I know.
Yeah, very interesting work. But I talked with him about it, and because he's an engineer, he was getting people to write papers on the Big Bang, on relativity, on black holes, those kinds of things. And he would suggest that they look on all sides, that they don't say, okay, the Big Bang is totally for sure, and we are totally happy with it. Why don't you look at maybe some criticism? Maybe some of the other ideas like an eternal universe where it's more like soup. And he did that for a number of years, but he was actually then his students started talking with their advisors saying he was sort of teaching thing. And again, I'm not here to harp on that, but I think it's important for people to understand how is it people are in the real world, have real jobs, and in case you're a physics person, you said you have tenure, that helps. You also do have controversial ideas, but it's not so far out that your students go away. Do you have some students that sort of complain about it, that it's a little too far, too out there?
There are students who they don't know about this subject because Weber's electrodynamics and relational mechanics is not taught nowadays at the universities. So
I see.
So it's new material for them. But
okay.
After they learn about it, they love it, and so.
Oh, very good, very good. Okay, that's cool. Now, let me just, because a lot of our viewers, most of them are science lovers and quite a bit allowed. It's not like we're doing this for the CNPS where we have, people who are pretty well versed. Now, I know that you have actually taken your, we'll start it this way, pretty easy, where we talked about the bucket, this idea that when you swing a bucket around, that the water stays in and it actually comes convex. And we'll get to something that in our particle model, from my father and I, he said something to me when he was working on a particle model for gravity, and when he solved the wave particle duality with using the same particle for light and gravity. But he said something to me, and he says, gravity comes from all the stars. And I thought, that's funny. I heard that from someone, a crazy Brazilian friend of mine who I like his work, but I never really thought about it. I thought it was a little crazy. And then here I am, who I'm piggybacking off my father's work. We have both contributed a lot to this particle model from all the things I learned, all the things that he did. And here we are back right to the same question. I go, I'm eating my words, as we say in Portuguese.
Yes, I know.
And can you explain a little bit about, it sounds like such a simple problem, right? We all know, when you really think about the mechanics of it, what happens? I'll let you speak on that.
Yes, this is a fascinating problem, this experiment was originally performed by Isaac Newton. He presented the bucket experiment in the beginning of the Principia.
Right.
Just as the most important experiment in order for Newton to prove to his mind that absolute motion exists.
Yes.
And so he has a bucket with water, and the surface of the water is flat. Then he spins the bucket together with the water relative to the earth, to the ground. And then the water makes a parabolic shape.
Yes.
So Newton wants to understand, why is the surface parabolic?
Right.
So we might answer, well, it is because the water is spinning. but the question is, spinning relative to what?
Yes.
And Newton showed that it's this curvature of the water is not due to the rotation of the water relative to the bucket, nor relative to the ground, nor relative to the distant bodies in the universe, like the fixed stars.
Yes.
And so, according to Newton, this very simple experiment was a proof of motion of the water relative to empty, free space.
Mm-hmm.
And then 200 years later came the Austrian physicist Ernst Mach and said, Newton must be wrong.
Yes.
This curvature must be due to the rotation of the water relative to the distant bodies in the universe, like the fixed stars.
Yes.
And so this became known as Mach's principle.
Mm-hmm.
And this idea by Ernst Mach was very influential to Einstein when he created his general theory of relativity.
Yes.
But in the end, Einstein could not implement Mach's idea. Mach believed that if we could let the bucket at rest above a table, at rest relative to the ground, and if we could rotate all the stars around the axis of the bucket, the water should be parabolic.
Mm-hmm.
But Einstein liked this idea, but he could not implement this idea with his general theory of relativity.
Yes. That's really fascinating. Like I said, it's really amazing to me that when we were dealing with gravity as a particle, my father and I, for our movie Einstein Wrong, we did this experiment as described by Dr. Carrazzani, Ricardo Carrazzani, a physicist from Argentina who had found that the special relativity equations, that actually having two frames, both physically and mathematically, were redundant, and they are. But in that case, he was looking at, okay, gravity is caused by a Newtonian force, and that was something that Newton, of course, never. The thing I admire about Newton, and who was very, I think, much better than the attitude we have of today's scientists. People use mathematics, people use terms, they come up with invented concepts and invented attributes, and then they say that these things are real, and this is what, for instance, space-time, that's gravity. But in reality, Newton said very clearly, I have no idea what is really causing gravity. And that's why he really couldn't come up with an answer. Don't you agree? Or
yes. And he had some ideas in his mind, but he was never satisfied about the origin of the gravitational force, and so.
Yes, and if you look at our particle model, it's pretty simple. That is, the entire world's, the only thing that, this is very much like Glenn Borkert. I don't know if you know Glenn Borkert's work. We base our stuff on the infinity. Because the thing is that we believe the same thing. The assumptions are the universe has space. It's a three-dimensional space. In that, you have matter, and matter's in motion all the time. Everything's moving.
Yes.
And from that you get the world. Now the problem, one interesting fact in the model, that's again this idea that all these stars are spitting out stuff. It's a constant, how do you say, that's why I think the Big Bang is a little strange, because we see in the night sky stars being formed, stars growing, stars dying, all those things. There seems to be a very cyclical thing going on there. And so the idea that what you have is you have a star that somehow ignites, perhaps that attracts, mass. In this case, you have what we call G1 particles, what would be graviton kind of particles, and they also emit them. And those things are being shot out, and that the resultant of what gravity is are all these stars out there emitting this, and this becomes almost like a noise. It's just like this constant, almost like the background radiation that's coming at everything. And if you don't have that, if someplace you could go in space that those weren't there, you're not going to have gravity, because you have to have something pushing. So do you subscribe to the idea that gravity is a push from something?
Well, I don't know. if it is a push or not, but I know that gravity is connected with matter,
Right.
matter and motion. So
Right.
that must be the case. And so,
Right.
in a sense, we have the same
Right.
great picture. And
Right.
so,
Right. Well, if you think about it, one of the philosophical things that we talk about a lot in the CMPS, and a lot of us in the CMPS have come to the same conclusion after talking about it, because you don't really talk about it. Like, is there a pull? Pull in reality is just another name for a push. If you pull a cup towards you, that's a coffee cup, you're pushing it. You're pushing it via the handle.
I know.
So it's really just because I'm a linguist, it really, I think the word push and pull are really anthropomorphic. It's something that we as observers and beings need to know if something is coming toward us or something is going away. It really doesn't have to do with the physicality of the movement of that thing. And I think because of that, we have this idea that gravity is an attraction. And so that's one of the things I think people who get into this and start thinking about it have to think about. So let's get into your actual work. What are you you do lectures, you do teaching on relational mechanics. Can you explain
Yes.
a little bit about what is different from what you do? Because we have Maxwell's equations. You don't teach Maxwell's equations, do you?
I do teach in my university, yes.
Yes.
But
And
but when I work with Weber's electrodynamics, that is another paradigm,
so
which
you
is
go ahead.
based essentially on force between charged particles. The field concept does not come in with Weber's electrodynamics.
Right.
And so it's a completely different point of view to see the interaction between particles or charges.
Well, what's really amazing about that, Andre, is that's one of the things we're putting together a new website for the CMPS. It's criticalthinkers.info, and it's about being critical thinker. One of the things that you are saying, which is one of the great things that I sort of, we're trying to summarize in our new website. We have things like, what does it take to what's a critical thinker versus an intellectual? To me, I define an intellectual as a person who wants to appear smart. You go to the university, you repeat whatever they say, you may not agree with it, you may even have a different model that you want to, or you want to actually do an experiment to show flaws in it, but you don't. So you know the latest on the Higgs boson, you know the latest on LIGO, and you can repeat all those things, but that's not really being a critical thinker. A critical thinker, and one of the things, what I put as one of the four main things on our website to put across, one of them is that variety. I just came up with this phrase, I think just last week. I had many phrases, but I like this one. Variety is the engine of progress.
Okay.
That's
very nice.
And what it means is we're going to have a model, which we do now, which is a standard model, which just is really, in my opinion, really problematic because most of it's invented. And so you have a model, good or bad, but the problem is when the model fails, we have to take a step back and say, what are some other ideas? We've got this notion in physics now that we discover Newton, he's right. Then we get, he's wrong when we get close to the speed of light, so now we have Einstein. Oh, he's wrong in the middle of black holes, so now we're going to do string theory. And the idea is that maybe we have to sort of step back and come up with a whole different model. And what you're talking about is if I understand, is exactly that. You are saying to your students, there are two, not sort of like equations for the same thing. There are two very different ways to think about the same problem. Isn't that correct?
Yes, and that's fascinating because James Clerk Maxwell also saw the picture in this way, exactly in this way. When we read Maxwell's treatise,
yes,
he makes a comparison between the field theories of Faraday and himself, Maxwell, and the opposite point of view, which he calls the German physics or the German science, developed by Gauss and especially by Neumann and Weber.
Right.
And and Maxwell shows in his book that Weber's electrodynamics explains all the electrodynamic phenomena, but with a completely different picture or paradigm.
Yes.
So that's just fascinating.
Well, yeah, and this is one of the things that people don't understand. When we go back, many of us are trying to do, what my father and I are trying to do is do a physical model for everything, and see how far we can go. And so far, what's fascinating to us is we can't break it. Every time we think we don't have a solution in that model, we have a solution. Doesn't mean it's right or wrong, but what it means is it's a valid model. And this model may show us things that technically will show us how to do things we didn't try. But the problem is we can't even get there in the current system because that's not even allowed.
Yes, and I understand that. And for this reason, I try as hard as I can to present these other alternative points of view of Weber's electrodynamics, Ampere's force between current elements, and Mach's principle, and Hubble's ideas of an infinite universe without expansion.
Yes.
And so on.
Yes, and that's one of the things. So you do talk about an infinite universe without the expansion, which is one of the things. Yeah, yeah, that's kind of crazy, I think, in a lot of senses when you take a look at it. Now, have you generated students with these other models other than the Maxwell models? Have you generated theses?
Yes, of course. For instance, one of my last PhD thesis supervisions was from a student who made the first complete and commented translation of Ampere's masterpiece, the theory of electrodynamic phenomena uniquely deduced from experiment.
Wow.
And Ampère published this book in 1826 in French, and it was never translated to any other language until 2009. This student of mine, Shaib, made this PhD thesis, and he made a complete translation to Portuguese of Ampere's masterpiece, and later on we published this as a book in English.
Oh my
so
goodness.
It is now available, his first paper, 1820, and his main book, it's available in complete commented translation in English. So everyone can read it now.
Oh, wow. I need to get that. Is that available online?
Yes, if you go to in my homepage,
yes,
www.ifi.unicamp.br.
Okay, I'll put that
in.
Assis. Yes.
Then it is available there.
Okay, I will put that link
in the comments.
And it's also
available on Amazon as well.
Oh my goodness.
It's called Ampere's Electrodynamics, just that.
Man, we've got to get some of these students presenting in our conference. I think this
And you see, this is Ampere's force between current element does not appear in any textbook, almost any textbook nowadays. But Maxwell said that Ampere's force should always remain the most important formula of electrodynamics, the cardinal formula of electrodynamics. But it just disappeared from the textbooks because it is not compatible with Lorentz force law.
Wow. Now what do you subscribe that to? What is the obviously what you said, because it does subscribe to Lorentz force. What is the impetus, the reason that's happening, the bigger reason? Why isn't that? Because
Ampere's is not compatible with Lorentz, and therefore it's not compatible with Einstein theories.
Okay.
And so it was deleted from the textbooks.
Wow.
But you see, it must come back.
Yes, well, that's one of the things that we're doing. Here's something for you to think about, Andre. I have taken all the software from Wikipedia, As you know,
Yes.
Wikipedia doesn't allow for alternative ideas. And even the most scholarly, we'll take some of our most scholarly work from like Dr. James Maxwell and Earth expansion, which has
Yes.
incredible data for it. And we'll put him, just list him as one of the people who believe in an expanding Earth. They'll pull him out because they don't want people to know. And that's on Wikipedia. That's weird.
Yes, I
So we
know.
have created a Wikipedia. I took the exact same software, which is open source, and we have wiki.naturalphilosophy.org. One of the things that I'd like to talk to you about is to create these things that we can't create on Wikipedia
I know.
in an encyclopedic way. We do not allow anyone to edit our Wikipedia because, and I'll tell you why that is. It sounds like, well, that's not democratic. The reason is that Wikipedia has one giant flaw. The giant flaw in Wikipedia is that it's consensus. That is, what we try to do is here's the moon and everything that we as humans think to be true about the moon,
I know.
not ideas that maybe we don't agree with and things that we have to work on and alternative ideas. Those are not allowed. That's immediately brushed to pseudoscience and written out. One of the things I'd like to really start talking to you about is getting some of this work that you and your students are doing in Ampere to have you actually, what if you, this is what I did with James Maxwell, he's a doctor in geology,
I
very,
know him.
and
Yeah.
he wrote the best encyclopedic entry for our Wikipedia. So if a student wants to read as a student in college or university or in high school or wherever, wants to read an encyclopedic type article, not one that's full of, emotion, a very scholarly work. The best one is on ours because it won't be accepted. I'm thinking that what is in the Ampere's work and in English, all those things, and the work that you guys are doing, this should be in encyclopedic form, and we have a place for that.
Oh, that's great. Great to know. We must think about that possibility. Yes, sure.
Yeah, and I think it's very. We have another part on our website, and that is, and this new website is broken down into three things, and this is what I think you guys could contribute. We have the first thing is what are some of the problems with mainstream science? Because people don't understand why there's alternatives. The public believes that once we find a model or once we find equations, Newtonian or as Einstein or whoever it is, Maxwell, that we have found the answer, that everybody in the universe, all beings in the universe who are intelligent will come across these same things. They don't know that there are problems or are actually better models or two models for the same thing. One works better for this, one works better for that.
Yes, and I agree with this point of view. And for this reason, I always try to make comparisons in my
Yes.
works, in my books. For instance, this relational mechanics.
Yes.
1/3 of the book is devoted to Newtonian gravitational theory, just to show the properties and the problems, so that people can understand, for instance, the bucket experiment, the proportionality between inertial and gravitational mass, and all these topics. Then I present the critical thinkers, Ernst Mach, Berkeley, Leibniz,
Yes.
and then Einstein and the problems which Einstein created with his theories,
Yes.
special and general.
Yes.
And then only in the last 1/3 of the book, I consider relational mechanics and how it answers all those problems which were discussed in the previous part. And the same thing I try to do with the book on Weber's electrodynamics. I first begin with Maxwell's equations and so on, and then I present Weber's picture and make a comparison. Weber's versus Lorentz force law, or Ampère versus Grassmann, Biot, Savart, action at a distance versus field theory, and always presenting original quotations from Weber, Ampère, Maxwell, Faraday, Einstein.
Yeah,
And
this is just amazing. I've been so involved with all the we're so busy with all these things. I really wanted to talk one-on-one on with you on this. So I just think this is just fantastic. And and we're putting together this critical. We have the one that says mainstream flaws, and the reason we have to do it in a way to attract people's attention. People say you can say
I know.
thing. So we have a mainstream flaw. You can click on it, and then we have categories, and we put it in a magazine style. I'd like to get you involved with this. We also have people that we how do you destaca in Portuguese? Sorry, that we
Yes, I know.
highlight. We highlight, and
Yes,
that
yes.
I love to put you in there. And because what we do
Thank you.
is we put you in there, and we say we have like we literally market person. We say. Teaches alternative Weber mechanics as an
Yes,
alternative to Maxwell's, and then talk about it in a way that a person gets interested, point to your stuff, because what I'm finding is we have a website, and you've been involved with our community for a long
yes,
time.
yes.
It's been made for us. Now
I
we're
know.
getting enough people on the internet, and they're getting so tired of all this craziness of the Higgs boson and
I know.
iso spin and a quarter charge. I mean, it's just bizarre. People want a fresh voice of people who are rational and critical thinkers who are not afraid to say, yeah, Einstein caused some problems. Here's why. Let me show you why. And then once we do that, the next thing they want to know is, okay, all right, I see. Hey, there are some real problems. The next thing is they want to know about who are the people doing this, and they want to find out, are these crackpots? Are they people? And we find out that the majority of the MPA was actually founded on, many of them went to MIT and Harvard. These,
Okay, yes,
you had Dr. Was it Dr. John Chappell, got his degree from
yes,
Harvard. We have our principal scientist. She got her physics and math degree from MIT, and she works on Galilean electrodynamics, and
yes.
that's another voice. And then the third part of our website are new models and new theories. And what we need to put in there, and get this, Andre, look how ironic this is. We're going to put in the new models and new theories, Ampere's work.
I
I mean,
know.
that is
200 years
crazy.
old.
It's 200 years
Just
old.
200 years old. Yes,
I-
that's the new theory.
Go figure, go figure. But that's the way we got to treat it. We got to treat
I
it.
know,
And I
because
think,
it was uh, completely forgotten for more than 100 years.
yes. And you know
And the
who,
same
yes,
as regards Weber's
Weber's.
electrodynamics.
You know who is, I don't know, do you know who, if you've been following our group recently, we had a talk 2 times by the Dr. Alexander Unziger from Germany.
Yes,
He,
I
he's working on his own stuff, and guess what he's working on? Weber. Weber.
yes,
And so you guys need to get together. I think you guys would hit it off like crazy. He is a person who goes on lectures. This is really funny. I've done one of my videos on him. He starts out his lecture like this. He'll be in Germany, or he'll be in France. He'll be around Europe, and a lot of his lectures are in English. And so he'll start out, and he'll say, the first thing he says, and this is usually a university, he goes, okay, I'll give it a little German accent. You know what I'm going to talk about. Entonces, if you disagree and you want to leave, you can leave. And so he waits before he starts his lecture, and sure enough, you'll hear people rattling, and about 3 or 4 people get up and leave.
I know.
Because he basically says he thinks we should throw out, and I agree with him, particle physics back to the subatomic particles, because it's all been invented. It's not based on anything real. And this is a guy who is interviewing people who are Nobel Prize winners. Somehow Alexander gets in and is able to interview these guys without knowing
I know. I
that
know.
what is his ideas. But it's funny because he just started recently working on his own, and he's working with Weber. And who was the first person I thought? You. So that's really, really interesting. This is just fascinating. We've been almost 35 minutes here, but I'm going to stop it now. But
Yes,
I
okay.
do want to invite you. We're going to talk again. I'd love to have us talk about a little bit about the difference between, and talk about Ampere and what that means, so that our audience can get to learn this. And also, I want to work with you before we do this. We're not going to do this next week, but I'd like to.
I know.
I'd like to work with you in getting your profile done on our new website. It's not launched yet, so we're working hard at it. And I want to work with you also to start getting the information, because one of the things I'm having with my subscribers here, which are approaching 200 people who regularly watch this weekly, these videos, they are saying, where can I read about this? And that's what we want to do, is make the website so these things are automatically answered. They can go and they see Andre Assis from Brazil, what's this? Click on it, find out about this, and go to Ampere's new old model and read about it. And then
excellent.
And then I would like to put that in the Wikipedia, because when we put it in the Wikipedia form, we are saying to the world, this belongs in the encyclopedia of knowledge. It should never leave. Even if we have better things in the future, this is missing from the world.
I know.
So let's
excellent ideas.
Yeah,
yes,
so
let's work on these topics.
Let's absolutely work on that. And
later on we can make other interviews and conversations.
Absolutely. And one of the things and we'll talk about, and I'll be thinking with you, is maybe even for you to do a channel yourself. It doesn't have to be as frequent as me, but one of the things we're trying to do is get many voices out there. And maybe what you can do is talk about those other things that aren't in there, and have it so that people can have 5-10 minutes of something about Ampere, about something in your book that's interesting, and so I'm gonna work on you.
Okay.
Okay. All right. Well, listen. Thank you so much, Professor Andre.
And thank you so much, David. I'm very happy with this interview, with our long friendship, and that's just excellent. And you speak Portuguese. That's fascinating as well.
And you know what we can do too, and I'm not kidding. I want to talk to you and Luís. I can do it in Portuguese. I'm pretty fluent. I can speak.
Sure.
And so
perfectly Portuguese. Yeah.
Pretty good. If I drink a little cerveja,
and
caipirinha.
write as well.
Well, write not so much. Writing Portuguese, formal. What you read in what you say in Portuguese and what you write are almost like two different systems to do it correctly.
No, but you are pretty good at that as well.
Yeah, and so maybe one of the things is we could look into doing some of these in Portuguese if we think that there's an audience in Brazil that maybe would be interested in some of these. So
in English, that's fine.
Yeah, I think most of the people in Brazil who are learned, English is the so. Yeah. Okay. Well, thank you so much. And remember what I say to my audience here. I always say to everyone, don't take what anybody says on faith, not Andre, not myself. Read about it. Stay critical, stay thinking. That's the most important. And I am your science therapist. I'm trying to get all of you guys to be critical thinkers. Don't just read everything and believe it in the papers or what's on the internet. We have great people like Andre Assis and his students, and we're going to get more and more on there. Yes, I'm going to work on getting their work up, and so you can find it easily. Thank you so much again, Andre. Boa noite.
Thank you so much, David. Boa noite.
Obrigado. Ciao. Ciao for now. Ciao. That's my sign off. Portuguese and English. Ciao for now.